Hi, my name is John Rullan. I currently teach at Thomas Edison High School in Jamaica, New York. Today's topic of discussion is going to be interpreting routing tables. Routers use routing tables to make forwarding decisions to route packets to destination networks. The lookup process is based on the most specific route to the least specific. What that means is that the most specific route is the route with the leftmost common bits, or based on the longest match. The default route is an example of the least specific route and is used as a last resort, hence the name, gateway of last resort. Information found in the routing table consists of the following: directly connected networks, learned networks from routing protocols, the next hop router, outgoing or exit interface, which is the direction, as well as the metric. The following is an example of the output of a routing table. Parent routes. Parent routes are created automatically when you subnet. An example of this would be the 10.0.0/8 network. Child routes. Child routes are routes with a mask that is greater than the default classful mask, or in other words, a subnet. An example of this would be the 172.16.1.0/24. Since this is a Class B address, the subnet mask is greater than the default mask, which is /16. Level 1 routes. It is a parent route that does not have an exit interface or next hop address to send packets to. An example of this would be the 10.0.0/8 address. A level 2 route. A level 2 route is the same as a child route, which is a subnet of a classful network address. An ultimate route is a route with a mask equal to or less than the default classful mask. An example of this would be a Class C address with the default mask of a /24. Another example would be a subnet or summarized address, such as the 192.168.1.0/20 address. This would be an example of a CyDR address. Default route. Default route is known as a gateway of last resort. Packets whose destination network is not listed in the routing table are dropped by default. A default route forwards packets not listed in the routing table, usually in the direction of your ISP. As shown in the example output, when R1 has to route a packet that is not listed in his routing table, he will forward it to the 10.10.10.2 address, and who will then handle that packet accordingly. Load balancing. Routers place the best path with the lowest metric or lowest cost in the routing table. When a router has multiple paths to the same destination with the lowest cost, it will place both in the routing table and load balance between them. An example of load balancing is that R1 has two paths to the 10.10.10.8 network. As shown, it can send packets to the 10.10.10.2 and to the 10.10.10.6. And if you notice, this is the only route within this routing table that has two paths to it. Static routes. Static routes can be configured one of two ways. You can use the exit interface or the address of the next hop router. The exit interface is shown in the routing table as a directly connected network. When you use the address of the next hop router, it is displayed with the next hop router's address. Typically, you want to use the next hop router address on a multi-access network, and an example of this would be a frame relay multi-point network. Null zero routes. Well, this is not really explained in the curriculum, but it is used. And these routes are similar to a static route, but send routes to the bit bucket. Basically, they're sending them to nowhere. These are used to prevent loops and are also used to prevent traffic from private addresses from being sent to the ISP. Packets sent to a subnet that is not currently in use will be forwarded to the null zero interface instead of being sent to the ISP by way of the default route. So there you have a better look at the interpretation of a routing table. In closing, we discussed child and parent routes, level 1 and level 2 routes, default routes, load balancing, static routes, and last but not least, null zero routes. It's important for you to be able to identify the different types of routes found in routing tables when configuring and troubleshooting networks. My name is John Rullan. I currently teach at the Thomas Edison High School in Jamaica, Queens. I also teach at the Borough Manhattan Community College in downtown Manhattan. I've been an academy instructor for the last 10 years, and I train all the teachers, whether new or old, and provide all the professional development training that they need. I guess it's important for students to be able to interpret the routing tables so they can be able to identify the different types of routes and the way a router learns them, whether it's a default route, a static route, or even a null route for that matter. It's also important for when they're trying to troubleshoot a network. You know, some of the labs are very complex now. They have troubleshooting now within the curriculum. And if students don't know how to read basic outputs, then it's going to be very hard for them to troubleshoot networks. And my example is that in the real world, the network is already built, basically. So if they're going to go in as a network administrator, usually they're going to troubleshoot something that went wrong. And if they can't read these outputs, they're never going to be able to figure it out. Well, I think one of the most important things is to have a mentor. A lot of instructors are the only one in their school or maybe in their school district that is teaching Cisco. And they're the everything person. They have to teach it, they have to learn it. And it's very important to have someone to be able to rely on, maybe a mentor somewhere. It doesn't have to be someone in the city. It could be somewhere, you know, as far as Cisco goes, that you can, you know, depend on for when you don't understand things. I think it's very important for instructors to do that. Also, you know, it's very important for instructors to be able to research a lot of things. You know, the curriculum, it can't have everything in there. I mean, if they did that, it would be so huge that you'll never get through it. So there are gaps in there, and that most instructors, they basically go through the curriculum, and what they don't know, they don't teach. And I think that's really a weakness that a lot of instructors have. Well, a lot of instructors focus basically on the course content. They try to master it. What they don't do is practice the hands-on labs. And I think it's very important for them to be both proficient in the hands-on skills as well as course content. And we're too busy trying to teach our students that when our students have a problem doing some of the labs, the teachers never did it, and they can't really help them. And it's really not a good situation when the instructor can't complete something, and they basically rely on an instructor guide. When it's better that if an instructor is more proficient and could look at the problem and guide the students to where the answer is, as better than not knowing how to do it at all. So I think it's very important for an instructor to master both. The available resources. When I first started out, I too was one who, there was a network of guys learning this, but the problem was we really didn't have anyone there to fill in the gap for us. Eventually, I learned that there was a huge resource of people at our disposal that can actually guide us in the right direction and to assist us and to explain things to us that we, couldn't figure out on our own. So that resource there, really, exemplifies the Academy program and the resources as well as the tools that they make available to you.